How does an angle affect the motion of a projectile? There are two factors that affect the motion of a projectile: angle and the initial velocity. As the object is projected at a certain angle theta, it has an initial velocity labeled v sub o. This v sub o is the combination of the initial horizontal velocity and initial vertical velocity. Remember, the combination of the initial horizontal velocity and initial vertical velocity is the initial velocity. As the object moves through the parabolic path, at each point, the velocity is the result of the combination of the horizontal and vertical velocities. You will notice that the velocity vectors at each point in the parabolic path is represented by a green arrow. The dashed green arrow represents the velocities along x and y, while the green arrow represents the velocity at a particular instant in the parabolic path. The orange arrow represents the acceleration due to gravity. Suppose an object is projected with an initial velocity of 50 meters per second at an angle of 60 degrees. How are we going to solve for the initial horizontal velocity and initial vertical velocity? We can solve these velocities using trigonometric functions sine and cosine. To solve for the initial horizontal velocity, we use the equation initial velocity times cosine theta or cosine 60. Initial vertical velocity is equivalent to initial velocity times sine theta, or theta represents the angle, which is 60 for this particular problem. In solution, we can say that Vx is equivalent to 50 meters per second times cosine 60, which is 25 meters per second, while Vy or V initial velocity along y is 50 meters per second times sine 60, which is 43 meters per second. That is how we solve for the initial vertical and horizontal velocities of an object projected at an angle. To solve for problems related to objects projected at an angle, we use these equations for the x or horizontal component, wherein Vx is the horizontal velocity, Vi is the initial velocity, dx is the horizontal displacement or range, and t up down is the total time of flight of a projectile. For dy or vertical component, we have the following equations, wherein Viy is the initial vertical velocity, dy is the vertical displacement, t up is the time it takes for a projectile to reach maximum height, which is also equivalent to t down. And t up down is the total time of flight of a projectile, or t up times 2 or t down times 2. Let us apply the given equations in this problem. A baseball player hit a ball with an initial velocity of 32 meters per second at an angle theta of 30 degrees with a level ground. If air friction is neglected, how far from the baseball player will the ball land on the ground? In our problem, there are two quantities given: the initial velocity, which is 32 meters per second, and theta, which is 30 degrees. The required quantity is the range or the horizontal displacement. and it can be computed using the equation dx, or range, or horizontal displacement, is equivalent to vx times time, or vx times total time. In order to solve for the range or the horizontal displacement, we need to do the following steps. First, you need to solve first for the horizontal velocity. And the horizontal velocity can be computed using the equation initial velocity times cosine theta. And the answer is 27.7128 meter per second. And we need to solve the initial vertical velocity using the equation v initial times sine theta. And the answer is 16 meter per second. Now, you need to solve for the time it takes for the projectile to reach the maximum height and go back to the ground. So in order to solve for the range, you need to solve first for the time. So you can use the equation T up is equal to negative VIY, or initial vertical velocity, over G. Substituting the given quantities, we can solve for the T up, which is 63265 seconds. Now, we are ready to solve for our range, or dx, using the equation Vx T up down. So, substituting our Vx of 27.7128 meter per second and the time, which is 1.63265, since it is only the time it takes the projectile to reach the maximum height, you need to multiply it by 2 in order to compute for the total time of flight of the projectile. So, the answer for the range is 90.49 meter. So, this is how we solve problems using the given equations for objects projected at an angle. What if a ball is launched with an initial velocity of 30 meters per second, but at different angles? How are we going to know which angle, or at what angle, will the ball stay longest in air? And which angle will reach the maximum height? And the maximum range, or farthest? And which angles will reach the same range? The given questions can be answered through this animation. The balls represent the projection angles, like red for 15 degrees, green for 30 degrees, blue for 45 degrees, magenta for 60 degrees, cyan for 75 degrees, and yellow for 90 degrees. Observe the maximum height reached by the objects at these angles, and also the maximum range. Remember that the higher the object reaches, the longer it stays in the air. Observe the angles that reach the same range. Applying the concepts you learned, think about it. What should the monkey do in order to get the ball?